which means 1/2 in front. Y to the 7th means y to the 8th divided by 8 plus a constant c. Do not forget, this is an indefinite integral. So this is the same with 1/16, but now I have to go back. I have to replace y by x squared minus 6. Done. It was possible, very straightforward and quite easy, with the help of a substitution. At the very end, I have to go back to the notation, to the substitution I used, because the integral is in x, the answer has to be in x. I use this intermediate step to help me find the answer. But y has to be at the end replaced by what we substituted it for, or with. This is the method of substitution for indefinite integrals. It's a technique of integration other than the direct one. We are not learning other techniques of integration in this class, just the direct and the substitution. So now let's choose anything else. Feel free to choose anything you want. Okay, I will. 17. In 17, we have the integral from t squared e to negative t cubed dt. You choose the next one. Okay, look at this function. This time this is an f of t. This is f of t. Which portion of this bothers you? I know this is not a scientific way, but it's the easiest way to explain how to identify the substitution needed. I'm going to say let u be. What bothers you from all this?
E to the negative t to the third, the third.
The negative t to the third. See,
I don't like the e.
yes, e to t doesn't bother me. But e to negative t cubed, this piece bothers me. And I will have to denote it by something else. As long as I can find the differential. Can anyone give us the differential of u equals negative t to the third?
Negative 3t to the second dx.
Yes, but dt. Excellent.
dt.
Yes, because the function is in t, I have to use t. If the function were in x, I would have used dx. Awesome, that's it. That's the reason why I tortured you with that differential. Awesome. Good. Jump over all this. Let's see what happens here. This piece is easy. What do I replace it by? Just this piece for a moment. What do I replace this piece by? Please try. It's okay if you're wrong.
Would it be e to the negative 3t? All u?
We already denoted it.
Would it be e to the u?
E to u. Awesome. Stay with me. I need t squared. I have it. I need dt. I have it. But I'm missing this piece. Making up a number or a factor is always very easy. Negative 3 divided by negative 3. So now I have the negative 3 multiplied by t squared multiplied by dt, and I still have a negative 1/3 in front. Who cares? It's a number. So what do I replace negative 3 times t squared times dt by? That's it. I'm done. Negative 1/3 e to u plus a constant c. I have to go back and replace it, though, with what it was initially. So the answer is negative 1/3 e to negative t cubed plus a constant c. Done. Any questions? Any questions? Okay. So let's take a look. Let's choose something else.
Can we something like 25?
Yes, of course. 25. 25 is very good. It's similar to what we just did, the first one. But let's do it. 25. It's the integral from t squared, t cubed minus 1 to the 7th power, dt. Perfect. Good? What bothers you?
The 7th power.
Right, the 7th power on t cubed minus 1. Not the 7th power. You mean this, if I have one term, it's easy. But once I have two terms, that's a problem. As long as I can find du, with minor adjustments for a number, who cares? That's always easy. So, can anyone give us du?
T to the second minus 1.
That's 1 prime is 0.
Oh, I'm sorry. Du.
Exactly. So then, I have t squared. Yes. I have du. I'm sorry. I have dt. Yes. I don't have 3. Who cares? Multiplying by 3 and dividing by 3 never changed anything, ever. So now I do have the 3. Do I have 3t squared dt? Yes. So I have a 1/3 in front. Who cares? A tiny number. Can anyone change this integral entirely from t to u? You cannot have two variables in the same integral. Please understand that will not be possible. So please don't make that error. So, can anyone change this integral into an integral from t to an integral in u? Anyone, please? Please, anyone?
Would it be u squared? So u to the 7th?
Good. And all these?
So 3u squared?
All these?
So I'm going to say 3t?
All these are here.
Okay. Oh, du.
That's it. As simple as possible. 1/3 u to the 8th over 8 plus a constant c. 1 over 24. I have to change u back into t to the 3rd minus 1 to the 8th power plus a constant c. That's why we did all this. To get rid of these three pieces. These three pieces are in du. This piece is u to the 7th. Is that better? Is that better? Anyone?
A little confusing, but a little better.
Okay. Once you work on these problems, you'll see everything will fall into place. Let me choose another. I would like to choose 29. You can choose the next one, but I like to move on to definite, and we can come back. So 29 has e to t dt divided by 3 plus e to t. Okay, this is a different story. What bothers you now? What is the function? This is the function. This is f of t. What bothers you here? What is difficult to deal with in this function? In this function, the difficult part was something with 2 terms to the 7th power. That was difficult. That's why we denoted this by u. So I can have u to the 7th, which is very easy to deal with. But what is the problem here with this function? And why? Anyone?
I feel like it's e to t just because it's around
E to t is friendly. E to t is no problem. But what is the problem in this function?
ET.
E to t is not the
It's
problem.
a fraction.
Good, you have something. The denominator. Oops. 3 to t in the denominator is a problem.
I mean, I just put it back in the.
Because the reason why this is a problem is because it has 2 terms. 1 over a plus b, stuck. I'm stuck on that one. I can't simplify. I can't do anything. If the denominator has 2 terms like that, a plus b or a minus b. So that's my problem. So that's where I focus on. What do you think u should be? Any letter, u, y, whatever you want. What do you think the substitution should be to make it easy? I don't want 2 terms in the denominator. That's the problem now. Like I did not want 2 terms to raise to the 7th power. That's the problem. I don't want 2 terms in the denominator. So u should be
3.
plus, I cannot separate. I cannot just take a and forget about b.
E.
Yes, to t. That's it. Now I have to find du. If I find du, I'm in business. With a minor adjustment, the number is not a big deal. So if I can determine du, and it's easy and it's in the problem, I'm in business. So what is du for this function that we just created? Can anyone give us du for this?
E to the t. D, dt.
Exactly. I'm happy. Can anyone tell me why I'm happy?
Because it cancels out.
It doesn't cancel out. I replace it by du. So how would I change this integral entirely from t to u? It's okay if you're wrong, just give it a shot. How do I change this integral from t into an integral in u? Exactly. This is the du, and this is the u. It's du over u. Awesome. Now careful, which function prime, there's only one, whose derivative is 1 over u.
Natural log.
Excellent. Natural log of the absolute value of u. Now I have to replace u by 3 plus e to t. This is always positive. I will not need the absolute value. But initially, I have to write the absolute value. Awesome. Well done. See, I tortured you enough. So, natural log of 3 plus e to t plus a constant c, and this is done. So this is the technique of integration called substitution or substitution rule for indefinite integrals. Now, I'd like to move on to the definite integrals. There is a minor difference. Minor difference. Okay, allow me to choose the first one and then you choose the next. 59. The integral from, it's a definite integral, from -1 to 0, from x to the third dx, everything divided by 2 minus x to the fourth power 7. Good. Look at this function carefully and decide what would you try the substitution to be. Give me your assessment. What do you think? It's okay if you're wrong. You have all the information to come up with a substitution. And what do you think that should be?
Accumulate u equal to 2 minus x to the 4 raised to the 7th power.
Nope.
Oh, no.
Excellent. That's it. Can anyone give us du?
du would be
Now you understand, let's go back for a second. You understand that we did not ever use the power on something like this, right? Where's my first one, right? I did not use the power in the substitution. I only used x minus square minus 6 as y. The same thing here. We only used t cubed minus 1, not power 7. Because power 7 on one term is very easy. Power 7 on two terms is impossible. Almost. I'm exaggerating. Okay? So that's why here is the same idea. We don't want two terms in the denominator. Good. So then du. Can anyone give us du? Say it again.
I guess that was wrong.
We are talking about du. We're not talking about anything here. We have a substitution, and we want du for this function.
Negative 4x to the third.
Yes? We want the differential, not the derivative.
d of t
But it's in x.
dx.
Excellent. Perfect. Good. So now, let's see what we get. The integral, do not copy the limits of integration. These limits of integration are for x. X is between -1 and 0. Do not copy the limits of integration. Wait. So, can anyone tell us what this is? What do I replace this by?
u to the 3rd power.
That's it. Perfect. Now, do I have x cubed? Yes. Do I have dx? Yes. I'm missing the -4. Who cares? I multiply by -4 and divide by -4. Tiny number. I can always make up a factor. I just have to copy it. Now, I need to replace this. What do I replace it by? Exactly. And now careful. When x is the lower limit, plug it in, and please give me the lower limit for u. Negative 1 to the fourth is 1. 2 minus 1 is?
1.
That's it. Now we take the upper limit, plug it in, and please calculate and give me the upper limit for u.
2.
Exactly. Please understand that when x is between negative 1 and 0, u is between 1 and 2. You cannot copy the limits of integration that are valid for x to an integral in u. You have to determine the new limits of integration. So now this is negative 1/4, the integral from u to negative 7 du from 1 to 2. Negative 1/4. U to negative 7 is u to negative 6 over negative 6 from 1 to 2. For the definite integrals, we do not go back to the original variable. Who cares? I have the new limits of integration. The answer will be a number. We do not go back to the substitution. For the indefinite integrals, we always must go back. I cannot give the answer in u if the integral has t in it. But when it comes to definite integrals, the answer will be a number. It doesn't matter how we find a number. We do not go back to the previous, to the substitution. So this is 1 over 24, 4 times 6 with a negative. And this is u to 1 over u to the 6th from 1 to 2. So 1 over 24, when I plug in 2, I think I get 64 minus 1. Whatever that number is. So, recap. When we determine definite integrals or calculate definite integrals and we use a substitution, we do not go back to the substitution, but we cannot copy the limits of integration that we had for x to the limits of integration that we have to determine. They have to be determined. The new limits of integration cannot be the same. Okay, so let's look at one more. I think I still have time. Do I have time for one more? Yes, please. So forgive me and allow me to choose another one myself. And then we will, yes, let's do 45. And then we'll work on more if you want next time. And I'll let you choose with pleasure. So 45. So this is the integral from 0 to 1 from 3x squared e to x cubed dx. And this completes chapter 4. Okay,